Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is right view of binary tree, and it is an easy level problem. So this problem is a very standard problem and it is fairly simple. It says that we have been given a binary tree and we have to find the right view of it, and they've also defined the right view of a binary tree. It is the nodes or the set of nodes which are visible when the tree is viewed from the right side. So let me just explain you this thing with the help of an example. So if this is the binary tree that we have, so you will see that when you see it from the right, this is the first node that will be visible to you, and on this level this will be the node that will be visible to you, because if you see 3, 2 will be hidden from the right side. Similarly, this will be the node that will be visible to you, and finally this will be the final node that will be visible to you from the right side. So the set of nodes is 1, 3, 7 and 8. So this will be our final answer. Now how we can solve this problem? The idea is very simple. You will see that in all of these nodes there is one thing that is common. If at each level, let's say at this particular level, you go from left to right, 1 is the last node that is present at this particular level. Similarly, if at this particular level, if you go from left to right, 3 is the last node that you will encounter at this particular level. Now again, if at this particular level, if you are going from left to right, 7 will be the last node that you encounter at this particular level. So I believe you must have guessed it till now. You have to do something with level order traversal. Now if you try to do level order traversal on this particular tree, what will happen? For, let's say, this is the 0th level, this is the first level, this is the second level, and this is the third level. For each level, you can try to find out what is the last node in that particular level, and you don't even need to do anything to find it out specifically. What you can just do is, for example, if you're just traversing through level 1 from left to right, at each step you're just going to update your answer for level 1. Let me demonstrate it how. So let's say initially my answer vector has size 0, right? So initially I'll be at level 0, and I say that if the size of my answer vector is equals to my level, that means answer.size is equals to 0, I need to push back some value. So I will push back 0 at the end of my answer vector. Now again I move on to the next level. I again check whether my answer.size is equals to my level. Now remember, my level has become 1 and still the answer.size is equals to my level. So what is this statement denoting? That answer.size is equals to level. It is denoting that we are at a new level and we need to add something to my answer vector. That means I need to append a new value to my answer vector. So in this particular case, we're just going to append. So we'll do answer.pushback 2. Now as soon as this is appended, the size of the vector or the answer vector will become 2, and since my level is 1, this condition will no more get triggered as long as I'm at level 1. Now if this is true, we do this particular thing. Otherwise what we'll do, we'll just update the answer of level as node data, right? So what are we doing? Whenever we encounter a new level, we're just going to insert the first element in my answer vector. Otherwise, if we have already visited some nodes of this particular level before, what we'll do, we'll just update the answer for that particular level. Because anyways, we are just going to go from left to right, and let's say these are the elements from left to right. If you initially have 1, then 2 will overwrite 1, and then 3 will overwrite 2, and then 4 will overwrite 3. So eventually you will have the last element in your answer vector for each particular level, right? Similarly, when you move on to the next level, you will realize that the level has now become 2 and answer.size is also equals to 2. It is also equals to 2. So what you will do, you will insert a new value or push back a new value 4 at the end of the answer vector, and after you have pushed it back, again you will traverse from left to right, that is 4, 5, 6 and 7, and at each node, when you reach 5, you will update the value of answer of level as node value or node data, right? So just going to update this for all the values of 5, then 6 and then 7, and you just need to perform level order traversal. The rest of the things will be automatically taken care by this particular code. Right, so this was all about the problem of the day. Now let us have a look at the solution. So what I've done is I've created a queue of pairs. So the first part of the pair is the integer, which is going to denote the level of my binary tree or the level I am currently at, and the second part is going to denote the current node. So I initially push 0 and root into my queue and I initialize my answer vector. Now while queue is not empty, I initialize my level and node and I'll assign queue.front to these two values. Now I just pop back this particular element from my queue, and now I have a simple if condition that if answer.size is equals to level, I just push back this particular node data into my answer vector. Otherwise, I'll update my answer level as node data. Now what I do, as we do in a normal level order traversal, I check whether the left child of the current node is not null pointer. I'll push back this particular new node into my queue. So my level will get increased by 1 and the node will be node.left. Similarly, I check for the right child. If it is not null pointer, I'll push back this particular element into my queue. So again, level will increase by 1 and node right will be inserted into my queue. So at the end, I can just return my answer value, and this will be the final solution of today's problem. Let me just submit this and show you that this particular code works. So you see, passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach the more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.